Hello again. So this video is exciting to me because this is where the pyramids and the derivatives can become practical. I've been talking a lot of math jargon and I realized that it's quite hard to follow by a lot of people, and not a lot of people are inclined to follow it because their brain types aren't naturally hardwired to want to understand this, because it's a bit stressful to actually think in this fashion, and it also may not be a way that most people natively think, because it may be unnatural to perceive mathematics in this way. But nonetheless, this video will be about the first expressions that can be used in pyramids that are derived from the simplest divisions. In other words, these are the first mathematical systems that can appear and actually be practically turned into a functioning machine. In other videos, I was talking about the Planck length and the octave and addition. Adding the Planck length naturally creates ratios, being the colors gold, aqua, and red, and those ratios being 1.25 for aqua, 1.5 for gold, and 1.75 for red. So those natural ratios appear, those ratios appear naturally by the addition of the Planck length. For creating pyramids, you use the division of the Planck length. So, as I said, it's an XY grid, which I'll illustrate in the next video. The division is what actually is the function that you use to create pyramid systems. And you divide in the first harmonic, or the fundamental harmonic, which we'll be talking about today. It's a division of the one Planck length. So it's very simple and easy to understand. So there's one Planck length, and it is simply divided by a number, and starting with the first odd number and going up. So the numbers you divide the Planck length are always odd, because even numbers duplicate, and duplications are the same because they're just octaves. So for example, if you divided by 1 in this law, you would get 1. If you divided by 1 by 2, you would still get 1. If you divide 1 by 4, you still get 1. Once you scale it between the octave of 1 and 2. So you always use odd numbers to find new divisions. So the graph looks like this, basically. On the first column and the first harmonic, which we'll be talking about today, we'll be talking about the 3 first divisions that naturally appear. So it's quite simply 1 divided by, and the first being 3. The second being 1 divided by 5. The third, which we'll be talking about today, is 1 divided by 7. And that is the first 3 to appear, and the most powerful fundamental systems in the universe. The 1 divided by 3 equals exactly the equilateral triangle, which I think is very interesting. The 1 divided by 5 is phi, is directly related to phi, and has angles directly related to phi. And the 1 divided by 7 may not have a common name, but it is directly related to the ratios of 7. So this division is also the wave number inside the machine, as per the law. 1 divided by 3 has a natural wave number multiple of 3, so 3, 6, 12, 24, etc. 5 is the same, so 5, 10, 20, 40, and 7, 7, 14, 28, and so on. So that's how it works. The division naturally creates the wave number as well. Also the wave length and the angle, the fundamentals to creating pyramids. In other videos, I'll explain how waves fit inside the pyramid, and how there's different ways for the wavelengths to stack inside a pyramid. And why they exist. So the wavelengths have to fit in a pyramid as well. So that will be covered in future videos. But today we'll be talking about the first three divisions, and I have a whole series of slides which I'll show to illustrate that as best I can. And what I find interesting is, and this is a bit of trivia, I guessed all of these values way before I understood the mathematics. My intuition always has led me, and then the maths has to back it up. So you have to find the maths to back it up and make it precision to an absolute precise nature. But I knew, and I guessed them all. I guessed all of these. I wasn't aware of 7 at the time, but I knew the color of the triangle, and I even guessed the dimensions of the pyramid in the waves, the fundamental way the waves naturally stack inside that system, or the way it's actually used, in fact. So I guessed these things. I just knew it, and I have this evidence to show you in future videos when I'm going to show all of my diaries and hundreds and hundreds and hundreds of graphs and things that I've drawn. Before the maths was discovered, I knew that these wavelengths that kept coming up were assigned to certain angles. And it was just all intuitive based. Yet the maths predicts this. That's what's interesting. And I have a more impressive example of this intuition correlating with mathematics that I'll show in a later video. And yet to the most extreme example of the probability of this is, to me, unquestionable. You could work out the probability, but it's a 9-digit sequential number that was guessed correct with one submission, and it matched the same one that I had. So I'll do a whole video on that because it's fascinating and quite miraculous. So that was an attempt to track down the absolute dimensions of the machine, to be absolutely sure, because they're not cheap to build. So yes, these expressions are and can all be turned into pyramids and are the closest to source. So that's kind of the back view. And for practical purposes, this information is to teach people that these systems are universal, and these angles have these one colors assigned to them. These are the true colors assigned to these angles and cannot be mistaken for anything else. The nature of these angles are related to these colors, and that is what they are. When it began for me, when I was trying to understand, intuitively I knew that angle and color were related somehow. And the way it came through initially before the mathematics was that the steeper angles to me seemed like they got bluer, and the fatter angles seemed like they got sort of more greenish, reddish, orange. And I was just like, it just feels right to me. It feels right. There's like, it's the steep ones have my mind could see the analog they could see the relationship between angle and color, and steep angles felt bluer, and fatter angles, like steep ones, felt bluer, and wider ones felt greener. And I was just thinking of the Giza pyramid, and I was like, that feels like kind of orangish red. I was like thinking to that years ago, it's not like a blue pyramid or anything like that. And it does happen to calculate to be a reddish color if you calculate the angle. So I kind of made this vague map based off of intuition, and then the maths was found. I was like, yes, it's exactly like, well, not, it didn't line up exactly, but the approximations were very close. I had the right idea, but I did guess the system of 3 and the system of 5. I did guess that color for those systems and the dimensions of the pyramids, because the models I made are within a millimeter of the correct dimensions, and I've assigned the color to them, and it was correct as well. But anyway, so basically what we have is, I will put up the beginning slide now. So what you see on the screen is a graph that I've produced of how to visualize the Planck length and division. And it's got the values for these divisions. So you'll see that the Planck length is illustrated by length. And the message at the top, Planck length ratio is derived by division of Planck length unit. So it's simply just a division. So the 1 being the violet, which is the Planck length, and its values, violet representing 45 degrees, a unit of 1 or ratio of 1. The division is 1, so just 1. And the color is 401.2 nanometers. That's the equivalent of color. And there's also a reason I keep referring to color, and that is to do with spectral lines and how the pyramids use carrier waves. So that's why I'm always using color. And it's also a good way to visualize it because the color is an emotional registry as well for individuals. Like it is a real emotional thing. So the first one, then, being the green on the screen, is the 1 Planck length of 1 simply divided by 3. 1 divided by 3. That's all it is to get these ratios. So you have the 1, you divide it by 3. You instantly get the ratio, which is 1.33333. So 1.33333 times 3 equals 4. And 4 equals 1. Because the octave is always reduced to between 1 and 2. So 1.33333 as a ratio is actually 1 divided by 3. And on a calculator, you can just simply do this. You'll get the answer point. If you divide 1 by 3, you'll get 0.33333. You keep multiplying it until it equals 1.333. And down the bottom is the division. Simply divided by 3, it is 60 degrees, 60-degree pyramid. It is the equilateral triangle. That's the first derivative that equates is the first derivative equals the equilateral triangle, which is interesting because it's like that is a platonic, the platonic of platonics. So the first one is a triangle. And that's equivalent to 534.9 nanometers. And that's its color. And all of these colors on the screen are RBG approximations of converting wavelength to color. So it'll appear slightly different for every screen, but these approximations are close enough. So this green color, the approximations are the best that they can be illustrated. So the green color it's a green, but it has a slight bit of red in it, so it makes it kind of a slight yellowish. So it's not a green, but you can play with this color and you can look it up if you want. So that's the green. That is the green system and the equilateral pyramid structure. And so the equilateral triangle is in fact a color green in its true nature. Then you have a division. Moving on, the next one is the division of 5. So 1 Planck length divided by 5. And that gives you a value of 72 degrees, which directly relates to phi. And it is the angles found within the pentagon and the pentagram as a polygon of 5. Polygram of 5 and polygon of 5. 72 degrees is what shows up. So the number 5 literally represents 72 degrees. The number 3 represents 60 degrees. The number 1 is a circle and its derivatives of division 360 degrees calculated down to 45 degrees. So the 72 degrees system is the angle derived, extracted simply by dividing the 1 by 5 or dividing 45 degrees by 5. So we'll do that calculation quickly. 45 divided by 5 equals 9. 9 degrees times 2, 18 times 2, 36 times 2, 72. Because it's 72 degrees for practical usage. because the pyramids we use between 45 and 90 degrees. It has a ratio of 1.6. So that's the number, that's the ratio that represents 5. 1 divided by 5 will equal 1.6 once you put it between the octaves of 1 and 2. So it's simply 1 divided by 5, and that equals also, in color, 641.9 nanometers. And so what I find interesting is the pentagram, when it's illustrated, is most commonly illustrated in the color red, and that is its actual color, because that pentagram has the angle within it as well. Those polygrams have angle, and the angle, most people have illustrated or depicted it as being red, and in fact it is mathematically red, which I think is really interesting. So yeah, it's pretty much a primary red color, or yeah, red in the RGB system, the color assigned to create red in RGB display systems. So that's phi, the system of phi. The division of phi is related to phi, and it generates these values. And also, just to remind, that the divisions are also the wave number in the machine. So you must use these as wave numbers inside the machine as well. Divided by 3 is 3 wavelengths in the machine. Divided by 5 is 5 wavelengths in the machine. So, moving on to the last of the 3, which is the division of 7. So 1 length divided by 7. And this system naturally creates an angle of 51.4285 degrees. And you might think that this system is not divine because of the angle is not a perfect integer derivative, but this is not true. Now the angle might be off-putting for some people, but don't be discouraged by this. There's a reason that the angle has numbers behind it and it is not a perfect integer. But this is quite simply explained by understanding that this system is pure. It's just that the way we measure angle is derived, or the way we measure angle is set up to allow specific systems to be harmonic, namely the system of 1, 3, 5, and 9, not including 7. But in fact, this system is a pure integer, for the way that the universe recognizes angle is not measured around a 360-degree circle. It is simply by perfect integers of stacking, where the end meets the beginning, stacked around a circle. That is how it is recognized, and the angle is assigned specifically depending on each system that is used. So a circle divided by 3 would be the angling system for 3. A circle divided by 5 would be the system for 5, and a circle divided by 7 would be the system for 7. But there is in fact a number, a special magical number, which allows all of these numbers up until the number 9 to be perfect integers, and I'll explain this in another video. So if you have a specific angle for a circle, which is 360 degrees, or a specific number, you can derive all of these angles in perfect integers. So in this system, when I say angle, it is based off of the system of 360 degrees, which is universally, or globally agreed upon by, I guess, the world, is the way to measure angle. But I can assure you it is not a universal system. It is an invention which is practical and encompasses most harmonics, but not all of them. So another video will explain this, but moving on, the system of 7 is the last of the 3 and is a fully practical system. So Again, it has an angle of 51.4285 degrees, a ratio of 1.142857 degrees, and is quite simply division of 7, 1 divided by 7. It generates a color of 458.5 nanometers. So, those are basically the three systems that you can actually build into machines with the correct logic. But there is so much information on this, I will not explain that in this video, but quite simply move on to the next slide, which is another way to depict this. So in this slide, these are the waves stacked from 0 upwards to naturally create heights, and this slide will allow you to understand how the ratios work. So at the bottom of the screen, there is one Planck length depicted on the left. On the right, it depicts 2 Planck lengths. So for ratio, and to understand how I use ratios, this is the best slide for that. As I said, the ratios are always in between 1 and 2, because between 1, the octaves of 1 and 2, every possible combination exists. So it would make sense just to have a ratio between the numbers 1 and 2. So 1 Planck length is the minimum, and then 2. And as you can see, I've depicted the ratios in fraction form and decimal form. So starting off with the first being 1.142857, which is a system of 7. That is the ratio in decimal form. And in fraction form, it's 1 Planck length plus 1/7. Moving up to the equilateral system of 60 degrees, the ratio of 1.33333 is 1 Planck length plus 1/3. Moving up to the system of division of 5, which is phi, has a ratio of 1.6, or in fraction form, it is 1 plus 3/5. And so this is where the stacking physically appears between the Planck lengths and is a relationship between ratio and visualization of the actual waves stacked up. And as you'll see, interestingly enough, each of these stackings equal the number 8, because 8 is in fact 1. And these wavelengths, therefore, equal 1. So this is one of these wavelengths, which is what they are. So that's why you have these ratios, because the ratio is in fact saying how many Planck lengths equal this wavelength, if that makes any sense. In decimal and fraction up the top, you'll see that 2 equals 1. That's because 2 resets back to 1, because 2 Planck lengths is in fact equivalent to 1. So, moving to the next slide, this is how the ratios are viewed by the circumference of a circle, which is just another way to see the ratios. And by doing this, you actually get to generate the geometry as well. So the geometry is generated as per the video prior. The geometry is generated, but so is the angle. So, and this is where it's magical cool, because it's all interrelated and self-calculating. It's so simple, it's actually really hard to understand, because it's generating all these values and numbers and calculations by the simplest setups. The simplest things generate all of what you need to know as a foundation to create these machines. So starting with phi, which is the system to the left, you can see that the circumference of 1, so 1 revolution around the circle, plus 0.6 equals 1.6. So if you divide the star by 5, each section would equal 0.2. So 1, 0.2, 0.4, 0.6. So that's why the ratio is 1.6. And you can see where that falls. And where it falls is actually one of the nodal points of what generates the star, which actually generates the angle. The pentagram, which it's correctly called, star, has an angle of 36 degrees, and in the pyramids we use, that's actually 72 degrees. So this star represents just one octave less of the same system. It's still the same system, it's just a higher octave pyramid, but it's the same. So we know that one revolution around the circle plus 0.6 equals 1.6. It's 1 Planck length plus 3/5, or it's simply 1 Planck length divided by 5, which generates this wavelength, the wavelength of red, that ratio, that angle which was calculated being 36 or 72 degrees, the color, which is approximately 641.9 nanometers, and the wave number as well, being a minimum of 5. So this is all auto-generated quite simply by this simple visual calculation, which marries everything together quite nicely. Moving to the next system on the screen, which is the equilateral triangle, and it is physically depicted as an equilateral triangle. So the ratio of 1.33333 is 1 Planck length plus 1/3. So 1 revolution around the circle plus 1/3. And where it ends, where the nodal point appears, naturally generates a triangle, which is the triangle, which is a 60-degree equilateral system. So that system is the easiest to understand because it is the simplest of all to understand, and it is the first derivative from the Planck length. So this system would look exactly how it is on the screen. As a pyramid, as a cross-section of a pyramid, it would be this angle. And then moving to the system of 7, which is the ratio of 1.142857, is 1 Planck length plus 1/7. So 1 revolution around the circle plus 1/7. And again, it finds the same place to generate a star that has the same angle. So the angle exactly matches the wavelength, exactly matches the wave number. So this system has a minimum wave number of 7 because there are 7 points naturally generated. And this is the basic maths of how to derive all of the systems, with a few exceptions, and that is using multiples of the Planck length for these calculations. But for the ones depicted on the screen, it is that simple and automatically generated as a result of the unification of all of these systems. So just know that building pyramids with the correct angle and the correct height communicate directly with the hyperdimensions or the beginnings of this universe. And now moving to a whole series of slides just to depict the evolution of how this mathematics is derived for each system. So this is more of a visual thing for me to explain visually how it's all calculated quite simply by using the geometry. So here we have the 45-degree system, which is the Planck length, unison. Then moving to the next slide, this is the polygram generated as a result of that. And then we have the outline of the polygram generated left. And then we have the stacking from that outline around the circle to extract the true wave number that must exist inside the pyramid. And so this generates, as you can see, a 45-degree pyramid of 401.21 nanometers, which is an 8-wavelength system, because that's how many pyramids stack together around one revolution of a circle. 1 Planck length being the circumference of a circle divided by 8 equals all of these values. And then moving on to just the stacking of the pyramids and the polygon that's generated around the outside. And again, the polygon reversed back to the geometry without the circumference of the circle. Moving to the equilateral 60-degree system, you see the circle with the triangle or the pyramid with inside that. Moving to the next slide, you can see the natural minimum polygon which is generated around the circumference of a circle, encompassing the triangle within. And the next slide, just leaving the polygon left around the circumference of the circle in order to stack pyramids of that angle together to derive the minimum wave number for that system. And so this has automatically generated a pyramid of 60 degrees that is 534.9 nanometers, which is equivalent to 6 wavelengths exactly. So the minimum number of wavelengths you can use for this system, and only multiples of are 6. So the minimum would be 6, and then 12, 24, etc. So 1 Planck length, being the circumference of the circle, divided by 6 equates all of these values. And then moving on, we just see the stacking. And again, the polygon stacking, but reversed back to the triangle. Now moving on to the 72-degree system, the circumference of the circle being the Planck length. And here we see the angle of this pyramid and what it looks like also. So this is a 72 degrees pyramid. Then, if we stack this pyramid around the circumference of the circle with the center apex being at the center of the circle, we see that the perfect and minimum wave number automatically equals 5 because there's 5 perfect stackings. In other words, 72 degrees times 5 equals 360 degrees. And that equals 5 wavelengths in number. So now we know 1 Planck length being the circumference of a circle divided by 5 equals these values. 72 degrees pyramid with 5 wavelengths within it, also equaling 641.9 nanometers. So this is essentially the universal system of phi. And again, we see just the pentagon with its pyramids stacked around. And now just the pentagon with the circumference of the Planck length. And now the octave above, the circumference of the circle being a Planck length, and 36 degrees polygram that is generated. So 36 degrees equals half of 72 degrees. And that generates the pentagram, which is also, again, that color. Moving to the next and last of the systems, the system of 7, automatically generating an angle of 51.4285 degrees. The pyramid cross-section looking like the triangle on the screen. That is the steepness of this pyramid in its visual form, as represented the same with the other pyramids that we've just previously represented. Then the stacking of this system perfectly stacks to equal the number 7. So this system has 7 wavelengths in it, minimum. So simply 360 degrees divided by 7. And this slide depicting the wave number around the circumference of the circle, like the other slides, the way it stacks, and its values. So we now know that the 51.4285 degree pyramid equals 458.5 nanometers and is a 7 wavelength system. 1 Planck length being the circumference of the circle divided by 7, automatically generates these values. And then moving on, we just see the polygon with this stacking of this pyramid. And the next slide, we see the polygon around the circumference of the Planck length. And then the next slide, we see the circumference of the circle being the Planck length and its octave above. So 25.7142 degrees depicted in this slide equals half of 51.4285 degrees. And this generates what is known as, I think, the pentacle, or a symbol which I've obviously forgotten the name of, which is a 7-pointed star. And all throughout history and culture, this is a used symbol that has specific meanings, etc., etc. But this, in fact, this color, as per the other colors, this is the true color of this symbol that is depicted on the screen, because that is its true mathematical derivative. And staring at these symbols has an emotional effect of varying nature. And I think that it's a feedback system. So by simply staring at these symbols and looking at the corresponding color, you can gain insights to these systems and these awarenesses as well, which is another topic of interest, verging away from the mathematics, but more to the philosophy of how and why these symbols affect the mind in certain ways. So that's pretty much the expression of these derivatives, which I've explained the best way that I can. These are the first systems that can be created in the universe, and these systems have great power because of their simplicity. They are the most closely related to the source, being the one. They have different functions and they tune to different places. And they're set up different with different logic because of the different wave number systems, which I understand how to build them as machines. However, they are not the path which I choose to go down because they are not native to the system which came first. However, understanding these systems came as a side effect from the one path that I did follow, because all of the mathematics is interchangeable. One system predicts and reveals information about the other. As long as the foundation is correct, you can understand all simply by understanding the true logic of the one. So, yeah, I think it's pretty cool. They speak to me. They all need to be converted to machines one day. But more importantly, these systems need to be understood that they have legitimacy to them and they have great value for us as humans. When people begin to understand that, then these systems will be focused on more so by the public domain, and hopefully in my lifetime they will be created because people will want them. I don't really want to build these myself, but if I must, I must. We'll see, time will tell, and it's my job currently to present this information, which I'm doing, and just to put it out there. And some people may be interested in it, some people might be displeased with what I'm saying, but either way, the information will be printed in time and should always be available, so that if people are pursuing these things and these trains of thought, at least that they will have the foundation and a head start in this research and not be looking for the needle in the haystack, which I did for many years. So yeah, that's basically the first part of this series. I'll continue making these videos focusing on other aspects of the machine, but that's basically the conclusion to the foundation of the geometry. In the other series, I'll explain so many more subsystems, such as how a pyramid actually works and why a pyramid, all about the pyramid. But this is like the math that kind of comes before a pyramid. So I think starting with the foundation first is essential. I hope you enjoyed. Goodbye.